Welcome back to Larry's classroom. Today we're going to learn about adding fractions. Start with an example here. Two ninths plus 4/7, or 4/9, I mean 2 ninths plus 4/9 equals. Now, important thing is to add fractions, the denominators have to be the same. And here we see that both denominators are 9. So we can simply add the numerators. 2 plus 4 equals 6. And we keep the same denominator, 6 9. We've added ninths, we ended up with ninths. Now, if you take a look at this fraction, we've talked about reducing fractions to lowest terms and getting rid of common factors. You can notice that 6 is equal to 2 times 3, and 9 is equal to 3 times 3. Now this here 3 over 3 here is what I often call a fancy 1, which means we can just get rid of it, cross it out. We got rid of a factor of 3 in the numerator and a factor of 3 in the denominator. We do not change the value of the fraction. We have an equivalent fraction, 2/3. So when we added 2 ninths to 4 ninths, we ended up with 6 ninths. We reduced that to an equivalent fraction of 2/3. And the real important thing here is that the denominators must be the same. Be the same. We could not add, say, 2 ninths plus 3/5. These would be different denominators. That would be a bad news thing. It would not work. So the very most important thing about adding fractions, like denominators. And we'll display this as just like an algebraic formula. Basically, a over d is one fraction. We add to it c over d. And the way it's done, it becomes a plus c, then the sum of the values in the numerator, over d, the common denominator. So we got to get a common denominator in order to add the fractions. And as we've talked about many times, if we do the same operation in the numerator as we did to the denominator, say we have this fraction here, a over d. If we said a times some number, we'll call it c, over d times the same number. We do not change the value of the fraction, so we have equivalent fractions which have the same mathematical value. Equivalent fractions. By the same token, if rather than multiplying, we did a divided by, we'll do a different function number this time, we'll call it g. A divided by g over d divided by g, or any similar number. As we do the same division to the numerator as we did to the denominator, we still have equivalent fractions. So when the denominators of the two numbers, the two fractions that we wish to add together, say we had a over d plus b over c, now these are not the same. We got to do operations to one or the other of these fractions, possibly to both of them, to get equivalent fractions, an equivalent fraction a over d, an equivalent fraction to b over c, that end up having both the same denominator. Then we can add the numerators as we talked about a few minutes ago, and everything will work out just wonderful for us. So we'll do a few more examples. A couple of fractions here. 3/4, 3/4, plus 1/8, 1/8, Well, we have different denominators here. We need to get them to be the same denominator. It's nice to use the least common denominator because we will have less reducing to be done in the end, but it is not an absolute must. If you use other than the least common denominator, you'll still get an equivalent fraction to the proper answer, but you may have to do more reducing. But in this case, it's pretty easy to see that the least common denominator is going to be 8. So we'll rewrite this. We'll say that 3 times 2 over 4 times 2, equivalent fraction, we've multiplied the 3/4 times the numerator and the denominator by 2, which I many times have called a magic, or a fancy one, excuse me, plus 1/8. Now we're going to do this calculation here. 3 times 2 is 6. 4 times 2 is 8. The 1/8 don't change. Now we have a lovely little common denominator here, which allows us to add them fractions directly together. 3/4, 3 times 2 over 4 times 2, and 6 over 8 are all equivalent fractions. So we had the 1/8, we didn't have to change that. Our goal here was to get an 8 for the denominator first fraction. Well, we add this together. We're going to take it down here. 6/8 plus 1 over 8 equals 7 over 8. Now, we always want to look at our fraction, see if it's been our fraction of our answer, to see if it's in lowest terms. Well, you may recall that 7 is prime, so which means the only factors of 7 are 1 and 7. Well, 1 is a factor of every number, so we don't really need to consider that. If we divide 7 by 1, let's do that. Just 7 over 1 divided by 8 over 1 gives us back, it doesn't change anything divided by 1. So the only other factor that we have of 7 here is the 7 itself. Well, 8 is not divisible by 7, so we know that we have got the final answer in lowest terms. There are no common factors in the numerator and the denominator. So we have completed our problem, and we know that 3/4 plus 1/8 is equal to 7/8. We've arrived at a successful answer for our question. Do a few more here. What else have I got on my list here? Okay. We're going to do another example. 2/3 plus 1/5. Now we want to find a number that's divisible by 3 and divisible by 5. Well, if we go count by 3s, 3, let's do that. 3, 9, 12, 15. Oh, there's a number that's divisible by 3 and divisible by 5. If we count by 5s, we go 5, 10, 15. There we found the same number. So it appears that in this case, 15 will be the least common denominator. We basically found multiples of 3 and multiples of 5, and there we found them to converge. So we want to put these two fractions, we want to find equivalent fractions for each of them as a denominator of 15. Well, 3 times 5 is 15, so we can deal with the 2 over 3 by multiplying the numerator and the denominator by 5. And again, 3 times 5 is 15, so for the 1/5, we can deal with that by multiplying both the numerator and the denominator by 3 this time. 3. You notice that we're going to have a 15 for the denominator of both of these after we do the multiplication. So we end up with 2 times 5 is 10 over 15 plus 1 times 3 is 3 over 5 times 3 is 15. So we have here 2/3, 10 over 15 are equivalent fractions. 1/5, 3 over 15, or 3/15 are equivalent fractions. And we have, as we always said we needed for adding fractions, we have the same denominator. So let's carry that down here. 10 over 15 plus 3 over 15. Now when we got the same denominator, remember our little formula, A over D plus B over D equals A plus B over D. Well, D is 15, our common denominator. A is the 10, and B is the 3, so we can do the same thing. 10 plus 3 over 15. So here we've applied this formula. Basically, we're just finding a common denominator, and then we're adding the numerators. So we add the numerator, the result is 13 over 15. And you may recall that 13 is also a prime number. So the only factors are 1 and 3, and the factor of 1 helps us none in reducing a fraction, so we're only, or 1 and 13, excuse me. So we're interested in the factor of 13. Is 13 a factor of 15? No, it is not. So we are in least terms here. And we have concluded that 2 over 3 plus 1 over 5 is equal to 13 over 15. And the important thing was putting the two denominators to make a common denominator. In this case, we found multiples of 3 and multiples of 5 and determined which one was the least multiple. So we found the least common denominator that way. But 3 and 5 are both prime, so doing the multiples led us right to the least common denominator. It is not absolutely vital you have least common denominator, but you do need a common denominator, and you do need these to be equivalent fractions and these to be equivalent fractions. If you find the least common denominator before you add the fractions, you're likely to have less work to do afterwards. Whichever method you choose, you need a common denominator and you need equivalent fractions, and it is desirable to reduce your result, your answer, to lowest terms. Which lowest terms means, and we've talked about this, but just to remind you, lowest terms means there are no factors in the denominator. There are also factors in the numerator. No common factors between the numerator and denominator. That is the meaning of lowest terms. We'll do one more example. We're going to do a number of examples. 3 over 6 plus 1 over 8. Now here, neither of these are prime. We could count up by 6s and we count up by 8s. Let's do that real quick. Counting up by 6, multiples of 6, 6, 12, 18, 24, 30, 36, 42, 48. Those are multiples of 6. We start with 8, find multiples of 8, 8, and then 16, 24, 30, I didn't do that right, 30, 32, 40, 48. Now we have found a couple. Here's a potential common denominator, 24. Here's another potential common denominator. We could convert this to 24s. We could convert this to 48s, and it would work out wonderfully. Let's see which. This appears to be the lowest common denominator, but let's Let's factor each of these, the 6 and the 8, into prime factors. Well, 6 is equal to 2 times 3. And 8 is equal to 2 times 2 times 2. 2 is a prime number, 3 is a prime number. So we have what we call prime factorizations. We have a list of products of prime factors which will equal the desired number. Let's write this in a little different format here. 6 is equal to, we have a single factor of 2 and a single factor of 3. Eight is equal to 2 times 2 times 2. This is kind of a nice format because if we carry down each factor as it appears in each number of times it appears, well, 2 appears in both as a factor in both 6 and 8, so we bring the 2 down here. Here's another 2 in the 8, so we bring this down. Here's another 2 in the 8, we bring that down. And here's a 3 in the 6, we bring that down. So we have found the prime factors that are going to be in the lowest common denominator. And we've done that by using the number of factors of 2, the maximum number of times it was used. And there was 3 of them in here. In 8, there was 3 2's. In the 8, there was 1 2 in the 6, and there was also 1 3 in the 6th. So there's a single factor of 2 in the 6, and we have at least one factor of 2 here. There's a single factor of 3 in the 6, so we have at least one factor of 3. There are 3 factors of 2 in the prime factorization 8, and we have at least 3 factors of 2 in our factorization for our lowest common denominator. So let's multiply that. 2 times 2 is 4, times 2 is 8, times 3 is 24. So 24 is our lowest common denominator between 6 and 8. Now another thing we can do with this little table here, it's kind of a handy little table for figuring out both the prime factorizations and for figuring out which you need to multiply these denominators by to get that least common denominator. I mean, this one's fairly easy to see, but I'm going to use green. I'm putting the ones in the 6 that are also in the 8 that are missing. Well, I've got a 4. I'm going to put a square box around those, or excuse me, a 2. A 2. I've got a 2, and I'm going to put a box around that. And another 2. So what we have here, what factors in the prime factorization of 6 that are missing from the prime factorization of the lowest common denominator? And that's 2 times 2. We have 2 times 2 equals 4. So 4 is going to be our multiplier. And you'll note that 4 times 6 does in fact equal 24. We're going to do the same thing for 8. Well, the only thing in the 8 that's missing from the prime factorization of the lowest common denominator is this single 3. So we're going to put that in a box. So we'll need to multiply 8 by 3. So we're going to put that in a box over here. And you will note that 3 times 8 does in fact equal 24. So this gives you a method of finding the required multiplier to put your fractions into equivalent fractions with like terms. So we're going to do that over here. 3 over 6. And for 6 we found we need a 4, so we're going to put a 4 here. 4 over 4, another what I like to call a fancy 1. Because Multiplying by 1, don't change the value. We still have an equivalent fraction. 1 over 8. And for the 8, we need a multiplier of 3. Another fancy one, 3 over 3. So we're going to multiply this out and bring it down. 3 over 4 is 12. 6 over 4 is 24. 1 times 3, 3 times 4 is 12. 6 times 4 is 24. That's here. 1 times 3 was 3. 8 times 3 is 24. So now we have equivalent fractions. 12 24ths and 3 sixths are equivalent fractions. 3 24ths and 1/8 are equivalent fractions. So now we have equivalent fractions with the same denominator, very important for adding fractions. So we can just add them up. We can say 12 plus 3 over 24. We're utilizing this little formula we gave you. Equals 15 over 24. Now, it's always desirable to put the answer in least terms. You probably already see that 15 is divisible by 5, or by 3. 15 is divisible by 3, and 24 is also divisible by 3. So we can do this. We can say 15 over 3, 24 over 3, 15 over 24 equals 15 over 3 divided by 24 over 3. What we've done here, we've divided the numerator by 3 and the denominator by 3. Another magic 1. We've divided by a magic 1, or a fancy 1, as I sometimes like to call it. And by dividing the numerator and the denominator by the same number, we will end up with equivalent fractions. So let's do the division. 15 divided by 3 is 5. 24 divided by 3 is 8. Now the next question is this, we've done a reduction, have we reduced it to least terms? Well, 5 being prime, the only factors are 1 and 5, and the 1 does nothing for reducing the fraction. So 5 is divisible by 5, but 8 is not divisible by 5. So we do not have any common factors, therefore this is in least terms. And we have successfully added 3 sixths plus 1/8 is equal to 5/8. And have I done that correctly? I believe I have. Did 24, 15. I'm going to check it with my calculator just to make sure that comes out like I thought it should. 3 divided by 6 plus 1 divided by 8. Yes, comes out to 5/8. So we have done our, I checked that by converting these to decimals, adding them with the calculator, and going for 0.625, and 5/8 is in fact equal to 0.625. I know that from memory, but you would probably be able to do that in your calculator if necessary. So we've done another example. This time it wasn't quite as easy to find the least common denominator because we had to change both the 6 and the 8. The last one we had a 4 and 8, we only had to change the 4. This time we had to change both of them. Leave that formula up there because it's kind of handy for adding the fractions. So let's see. Okay, we're going to do another one here. This one's a little more complicated. 17 over 20 plus 3 over 15, 17/20 plus 3/15 plus, or minus, now we're going to subtract, minus 7/12. Well, let's find the least common denominator doing the prime factorization method. With 20, we have factors of 2, 2, and 5. These are prime factors. 2 times 2 is 4 times 5 is 20. Let's do the same thing with 15. Well, 15, we have a 3 and a 5. 3 times, these are prime numbers. 3 times 5 is 15. And for number 12, we're going to do, what do we have here? We have 2 times 2 times 3. And you will note that 2 times 2 is 4 times 3 is 12. So we have successfully found, now everything here is prime. So we successfully found our prime factorizations for 20, 15, and 12. Now we got to find the prime factors that exist in the least common denominator. Well, we got to bring down a 2 here because there's at least 1 2 in those two. Bring down another 2 because these two have at least 2 2's in their prime factorization. Bring down the 3 because a 3 occurs in 12 and 15. Bring down the 5 because a 5 occurs in 20 and 15. Let's multiply that out. 2 times 2 is 4. Times 3 is 12. Times 5 is 60. So we have a LCD, a least common denominator, 60. And now we want to find out what we have to multiply by to convert each of these into 60. Well, you can see the missing factor in the 20 is the 3. And in fact, 20 times 3 equals 60. The missing factor in the 15 is 2. There's 2 of those, which I'd like to put boxes here. And 2 times 2 is 4. And in fact, 15 times 4 equals 60. The missing factor in the 12 is the 5. And in fact, 12 times 5 equals 60. So these are the required multipliers: the 3 for the 20, the 4 for the 15, and the 5 for the 12 to put these into least common terms. Or least common denominator. So we're gonna do this. For the 20s, we're going to use 3. So we're going to 17 times 3 over 20 times 3. Plus, for the 15s, we're going to use 4. 15 times 4 over 15. This is 3 times 4, excuse me, 3 in the numerator. 3 times 4, 15 times 4. Minus, now we're going to subtract. But it works out the same way. If this had been a minus here, we would just use a minus there. It would, the same type of deal. We'd subtract across the numerator once we had the same denominator. Now for 12, we need a multiple of 5. So 7 times 5, 12 times 5. Now you notice we multiply this fraction by 1, we're going to have an equivalent fraction. We multiply this fraction by 1, we're going to have an equivalent fraction. We've multiplied this fraction by 1, we're going to have an equivalent fraction. 1 in the form of 3 over 3, 1 in the form of 4 over 4, and 1 in the form of 5 over 5. So let's do the multiplications here. 3 times 17, 51 over 60, plus 3 times 4, 12 over 60. All the bottoms, 60, 60. The denominators, minus 7 times 5, which is 35 over 60. So now we have a common denominator, 60 for every fraction. We have equivalent fraction, 51 over 60th, same as 17 20ths. 12 60ths, same as 3 15ths. 35 60ths, same as 7 12ths. So what we could do is just go 51 plus 12 minus 35 all over 60. We're just, now that we have the same denominator, we can just work across the numerator. And that ends up being 28 over 60. And we can see here, obviously this is not in least terms because they're both even numbers. We know they have a factor at least of 2, but actually they're both divisible by 4. So we're going to divide the numerator, 28, by 4, the common factor, and we're going to divide the denominator, 60, by 4, the common factor. Well, 28 divided by 4 is 7, which you'll note is prime. 60 divided by 4 is 15. The only factors of this prime number is 1 and 7. The 1 is not important for reducing the fraction. But is 15 divisible by 7? No. So we have this in least common terms. So this 17, well, I'm going to put it up here. This was equal to 7/15. Now, we've got several where we got a prime number. Do not get the idea that your numerator or your denominator has to be prime to be in least terms. Let's see if we can quickly come up with one. 8 over 15. 8 is not prime, nor is 15 is prime. What are the factors of 8? 2 times 2 times 2 is 8. What are the factors of 15? 3 times 5. So you know we have no common factors between this numerator and this denominator, but it is still in lowest terms. We've had a number that we've done a number of examples where we came up with a prime number. Do not assume that every fraction that is in least terms is going to have a prime in the numerator or denominator. Here's an example of one that does not. We've just kind of happened, I guess. Got lucky. I don't know if you call it getting lucky, but coincidental. We've had several of them like that, but do not believe that the numerator or the denominator of a fraction must be prime in order to be in least common terms, or least terms. And we're going to talk real quickly of an easily made error. If we have 1, this is an example, 4 ninths, 1 minus 4 over 9. Now we can make this be, 1 can be replaced with 9 over 9, minus 4 over 9. So we've just found equivalent fraction for 1, and we didn't need to find equivalent fraction for 4 ninths because we've got the desired denominator. And using this same little formula here, which works for addition or subtraction, I changed it a little bit ago to show you that. We have 9 minus 4. So adding and subtracting fractions is almost the same operation over 9. Now, you may look at them two 9s and think you can cancel them, but you cannot, because 9 is not a factor. What does this become? 9 minus 4? This is 5 over 9. Let's express this. Let's write another fraction. Let's say 10 minus 5 over 9. 10 minus 5 is also 5. So this and this are equivalent fractions. And if we were to take and cancel out the 9, what would we say? This is that 9 minus 4 over 9 is equal to negative 4 over 1, or negative 4? Which would be a big no-no. And I'm going to do the old circle around it because 9 is not a factor. Factors are something that will divide into, or something you can divide a number by. 9 minus 4, 5 is not divisible by 9 at all, is it? So be careful when you have a string of addition in your numerator or subtraction that you do not think you can cancel the numbers in that addition or subtraction string with the factors in the denominator. You will have erroneous results and you will not be happy. We're going to do another example here. 2 over 5 times 1/2 plus 7/8. Now, here you notice, remember the order of operations. It was parentheses, divide, multiply, and divide, and then addition and subtraction, add and subtract. So we don't have parentheses to deal with, but we have multiplication, division, we also have subtraction. So we need to do the multiplication before we do the addition and subtraction. Now this is not a required step, but to help remind us, I'm going to put a couple parentheses here. Not required, but it might help you remind us that we have to do this first. So let's do that. 2 over 5 times 1 over 2, 2/5 times 1/2. And remember, for multiplying fractions, we multiply the numerators, multiply the denominators. So that ends up being 2 times 1 is 2 over 10. And being the, so this 2/5 times 1/2 equals 2/10. It's fairly easy to see that the numerator and the denominator, being they're both even, are divisible by 2. So let's divide the numerator by 2. 2 divided by 2 is 1. 10 divided by 2, the denominator by 2, is 5. So we've reduced this result to lowest terms, which would not be essential, but it'll make it simpler, probably make our reduction need in the end a little simpler, and may also lead to a smaller lowest common denominator. So we can replace this piece with 1/5. I'm kind of draw an arrow here to show you that's what we've done. We calculated it, now we've replaced it. This remains as is, plus 7/8. And now we want to add that up. We need a common denominator. Rather than go through the prime factorization stuff, I'm just going to tell you the common denominator here. You might be able to see this. 5 and 8, being 5 is prime, it's going to be 5 times 8. So the least common denominator is going to be 40. So we're going to go 1 times 8 over 5 times 8, because 8 times 5 is 40. And we're going to add to it 7. Now we're going to go times 5, because that's the number we're going to multiply 8 times to get our lowest common denominator, 40. 5 times, we end up with 8 times 5. See, we've multiplied by an equivalent fraction to 1. So 1 times 8 is 8. 5 times 8 is 40. Plus 7 times 5 is 35. 8 times 5 is 40. Now we have a common denominator. We can add the numerators together, and 8 and 35 is 43 over 40. Now, we've come up with something. This is the first time I think that we've seen the numerator larger than the denominator. This is what they like to call a improper fraction. Now, I don't like the term improper fraction because it's mathematically fine, but we are not used to seeing it that way, and we often write them as what's called a mixed number. So let's take this 43 over 40, and let's write it in a different way. 43 over 40 could be 40 plus 3 over 40, correct? Now we can take this, we're just kind of doing what we did backwards when we found the common denominator. We're going to have a common denominator of 40. We're just taking this formula, well, make it back to a plus then, and we're moving back this way. So we can separate these two. That's 40 over 40 plus 3 over 40. And you can see this is the same thing as this, because we could use this formula and go back to what we got there. I want to separate this so you don't get confused here, because it's separate from. But what's 40 over 40? It's equal to 1. We've found what you might call equivalent fraction or equivalent number for 40 over 40, 1, plus 3 over 40. So this improper fraction, which is when the numerator is greater than the denominator, can be written as 1 plus 3/40. Same value. Same value. So we started with this. We applied the order of operations, found that we had to do the multiply first. I put parentheses on there, not necessary, but I put them on there when I discovered that, just to keep my eye focused on doing this part of the thing first. So I carried that down there. I did the multiplication. I reduced it to lowest terms. Then we substituted it here, and we brought the 7/8 down. Then we found the least common denominator, 40, used our proper multipliers to get it in that, in 40ths. We added them up. We found 43 over 40 to be our answer, which we called an improper fraction. We looked at how we changed an improper fraction into a mixed number. Let's write that down. Mixed number. Which is what that guy is. And it's mixed because we got a whole number and a fraction. It's a mixture of whole numbers and fractions. I don't like the term improper, because if you go further in math, you may find that many times you keep it in this form until you are done with the problem, because you end up converting to this, converting back, and this will work all the way through without any problem. And if you needed a mixed number in the end, you can do your conversion then. It's called improper, but there's nothing incorrect about it. How's that? Other than for a particular assignment, you may be asked to give your answers as mixed numbers rather than improper fractions. Okay, we're going to do one more here. 3 over 15. We're adding in multiplying. Well, we did multiplying and dividing fractions the last lesson, and now we are doing addition and subtraction of fractions, but we're giving examples that have both in there, because one reason is we want to get good at the order of operations. Now what do we got here? We got to subtract, we got to divide. Parentheses, divide, then add, subtract. Well, we got to divide. That's going to come ahead of the subtraction. This time I'm not going to put the parentheses I added to help your eye. I'm just going to ask you to remember that goes together. But we're going to rewrite this. 3/15, no problem, minus 3/18. We want this in the form of a fraction, so we're going to divide by 5 over 1. You can make any whole number into a fraction by giving it a denominator of 1, and you'll have an equivalent fraction. Now remember the rule for multiplication. It was invert and multiply. We take the divisor and use the reciprocal. So we're going to rewrite this, replacing that with a multiply. 3 over 15 minus 3/18. But now we're going to multiply by 1/5 rather than divide by 5. Multiply by the reciprocal gives you the same result as dividing by the original number. And multiply ahead of subtraction, so we want to work this out first. So we're at 3/15, subtract. Now here, we're going to do this without putting the parentheses. I could draw the parentheses, but 3 times 1 is 3. 18 times 5, what do I get for 18 times 5? Okay, this is supposed to be tenths. Okay, my example ain't doing what I wanted to do because this is tenths. That's why. Okay, we're going to review quickly. 3/15 minus 3/10 divided by 5. 3/15 minus 3/10 divided by 5 over 1. 3/15 minus 3/10 times 1 over 5. So now we're doing with tenths. 3 times 1 is 3, and our numerator is 50. Now we have a subtraction problem. Now we need to find a common denominator. The least common denominator is a nice way. I've worked this out myself and found that we need to multiply the least LCD equals 150. So we got to multiply this guy by 10 over 10 and this guy by 3 over 3. So let's do that. By 10 over 10 minus 3 times 50 over 15. Times. Oh, it's just 3 times 3. Yeah, 3 times 3. Times 15 times 3. So we've multiplied by 10 over 10, which equals 1. We've multiplied by 3 over 3, which equals 1. We end up 3 times 10 is 30 over 15 times 10, 150, minus 3 times 3 is 9 over 3 times 50. This was 50 here. Okay, this was 50. Yeah. 3/15 times 10 over 10. 3/50 times 3 over 3. 3 times 10 is 30. 15 times 10 is 150. 3 times 3 is 9. 50 times 3 is 150. Now we have a common denominator. We'll do the subtraction right across the top. Across the numerator, 30 minus 9 is 21 over 150. It's fairly easy to see that 21 is divisible by 3 and 150 is divisible by 3. So let's continue with that. 21 divided by 3, 7. Is that correct? 150 divided by 3, 50. I took a few shortcuts this time. I gave you the least common denominator. I didn't really write out the division part here. We just talked about it. So what it comes down to is this particular problem is equal to 7 over 50. So what do? First, we converted this to a fraction. Then we converted this to a multiply. Then we did the multiply, which was right here, 3 over 50. Then we found a common denominator. Then we did the subtraction. Then we found least terms by finding the common factor that was in both the numerator and the denominator. Okay. Looks like I got one more example and we'll be calling it a day. This is going to be a little bit of an electrical problem. don't know electrical symbols, so I'm going to just draw little pictures here. Now this is 10 ohms, excuse me. 10 ohms R3 is equal to 75 ohms. R equivalent. Now what we have here are 3 resistors connected in parallel. A 5 ohm resistor, a 10 ohm resistor, and a 75 ohm resistor. And we are interested in finding what the equivalent value of those, in other words, what single resistor could we replace those 3 with. Now the formula for that is 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. And now you can see we're going to be adding some fractions here, aren't we? So let's write that out. 1 over R, our equivalent resistance, is going to be 1 over R1 or 1 over 5 plus 1 over R2, 1 over 10 plus 1 over R3, which is 1 over 75. And resistance is measured in ohms, and we usually use the symbol, the Greek letter omega, to represent that. That's why I put this little omega here, omega here. So we have a bunch of fractions we have to add together, so we have to find a common denominator. Well, what's a common denominator for 5, 10, 75? 150 is a good common denominator. I believe the LCD is 150. So we're going to say that 1 over R is equal to, what do we got to multiply 5 times to get 150? It's 30. 1 times 30 over 5 times 30. What do we got to multiply 10 by to get 150? Well, that's going to be 15. 1 times 15 over 10 times 15. And what do we got to multiply 75 by to get 150? It's 2. 1 times 2 over 75 times 2. Now you'll note that 5 times 30 is 150, 10 times 15 is 150, 75 times 2 is 150. And here we got the 30 over 30, the 15 over 15, the 2 over 2. So we're going to do these. We'll say 1 over R is equal to 1 times 30, which is 30, over 150, plus 1 times 15, which is 15, over 150, plus 1 times 2, which is 2 over 150. Now we have a common denominator. So we can add these fractions just by adding the numerators up. So it's going to be 30 plus 15 plus 2 over 150, which is going to be equal to 47. 30 plus 15 is 45, plus 2 is 47 over 150. So we have found what 1 over R equals. So we have found the value of the reciprocal of the equivalent resistance. If we want to get all we want to do is, if we have 1 over R is equal to 47 over 150, being we want R, we're going to take the reciprocal of both sides. So which is just invert the fraction. So that says that R equals 150 over 47. Now you'll note that that is another improper fraction. We have the numerator greater than the denominator. So we could rewrite that as 47 plus 47 plus 47 plus 9 over 47 was our denominator. And we can rewrite that again as 47 over 47 plus 47 over 47 plus 47 over 47 plus 9 over 47. We're just taking our common denominator, we're separating the fractions. Basically doing this in reverse, going this way, and we have more fractions than this single example, and we can replace the 47 over 47, 1 plus 1 plus 1 plus 9 over 47. So this is equal to 3 plus 9 over 47. We've added the 1 plus 1 plus 1 to get 3. So we've come up with a mixed number, and basically our equivalent is equal to 3 plus 9/47 ohms. So when we put the 5, the 10, the 75 in parallel, we ended up with a 3 plus 9/47 ohm resistor. Would replace them all as a single resistor. And one thing you will notice, that this was a little bit less than 4, which is less than 5, less than 10, less than 75. When you put parallel resistors in parallel, the equivalent resistance is always going to be less than the smallest one. I think that kind of covers it for today. Appreciate you coming back. Remember, it's always a good idea to do some practice problems. You could take any math book and look at the things we've talked about and find the section that has the same thing and do practice problems out of there. Practicing is very important to develop your math skills, or you could go and find yourself a book in mathematics for electricity and electronics, and you'll find probably examples very similar to what we're doing here. But until the next time, remember to like and subscribe. And until the next time, keep on learning.